Okay, this will be a very quick example here, a very quick video. It says finding the square root of a complex number. So it says find the square root of 3 plus 4i. So for your solution, all you're going to do in this one is let the square root of 3 plus 4i equal a plus ib. Now I don't know if this is going to be an imaginary number, or a complex number, but I've allowed it to be, if it needs to be, a complex number. So it's got a real part and it's got an imaginary part, and we'll see what happens. Okay, all we're going to do here is square both sides. So square both sides to see what happens. So the left hand side is easy. If you square it, you're just going to get 3 plus 4i. If you square the right hand side, you're going to get a plus ib all squared. So 3 plus 4i equals, square the right hand side out. I'm going to write that out again just to make sure I don't mess anything up. So 3 plus 4i, right hand side is going to be a squared plus I times abi, or I times ab, and you have another one of them. So you have a times a gives you a squared, a times the ib gives you iab. You'll have another one of those. So what you've got really is 2iab, and also you're going to have ib times ib, which is going to be I squared times b squared, and I squared is minus 1, so it's minus b squared. All I'm going to do is rewrite this thing, and I'm going to group my real bits together. So a squared minus b squared, that's my real bit, and then my imaginary bit, and I'm going to take the I outside of bracket to AB, I should say. Okay, because I've set it out this way, it should be easy for you to see what the real bits are. So what I'm going to do is equate the real parts. Now this comes from what we had in our previous example. If I can scroll up without wrecking anything here. If z1 is equal to z2, then the real bits are equal. The two real bits are equal, and the two imaginary bits are equal. So this is really what we're using here. So I'm going to equate the reals. So my reals on the left hand side are 3. On the right hand side it's a squared minus b squared. And you can probably guess where I'm going with this. And then I'm going to equate the imaginaries. Excuse my handwriting. And you're going to have 4 is equal to 2ab. And I'm just going to tidy it up a wee bit and say that's 2 is equal to ab. And that's my equation 2. So I've got 2 equations and 2 unknowns, which you can then solve. So I'll just get down to what I need. So here, the way I've done it, I've just said b is equal to 2 over a. Therefore, my equation 1 becomes 3 is equal to a squared minus 2 over a all squared. And then we'll just do that out. That's going to be 3 is equal to a squared minus 4 over a squared. And what could I do now? I could multiply through by a squared to give me 3a squared. 3a squared is equal to a to the power 4 minus 4. Okay, bring everything to one side. You're going to have 0 is equal to a to the 4 minus 3a squared minus 4. And I think that will factorize. It will indeed, of course it will. That will factorize to give you a squared minus, a squared minus 4 upon a squared plus 1 is equal to 0. Okay, we're going to say then a squared is equal to 4, or a squared equals minus 1. Now let's put the brakes on a wee bit and go back to the start. We've got this far. This is your complex number. This is a complex number. A and B are real numbers. So we can't have this one because this would give you an imaginary number. So we'll just say A is real. So A is not equal to the square root of minus 1. So we can ignore that one. Okay, so we're just working with this one, which makes life an awful lot easier. So here, therefore, if a squared is equal to 4, that means a is equal to plus or minus 2. And if a is equal to plus or minus 2, therefore your b, so this is going back to your formula, remember b was equal to 2 over a. So that b is equal to either plus or minus 1. So your answer, therefore, the square root of it was 3 plus 4i is equal to 2 plus I, or it is equal to minus 2 minus I, and that's it. Okay, folks, as you can see, you're now ready to do P3 book, exercise 7C, and there's a list of questions here for you to do.